Welcome to this deep dive into my reverse pulse notation calculator project. Built using an Arduino Nano, a one-wire keypad, a custom stack library, and a liquid crystal display. This project brings together both hardware and software design in a compact, practical build that demonstrates voltage division, data structures, and efficient input handling all in one. Let's start with the keypad. Instead of using a standard matrix keypad, which would need several digit pins, I use a one-wire keypad based on voltage division. This setup uses a resistor ladder, 4 1 kilo ohm resistors and 3 4.7 kilo ohm resistors to form a voltage network. Each button press creates a unique path through these resistors, resulting in a distinct voltage level at the analog pin A5 on the Arduino Nano. The microcontroller reads these voltage levels as analog values from 0 to 1023 and uses a threshold array to determine exactly which button was pressed. This efficient use of just one analog pin frees up space on the microcontroller for other peripherals like the LCD. Each key press is mapped to specific character, digit, operators, and special functions like enter, which are processed in real time using the get key and the get entry function in the code. To manage operations, I created a custom stack library. In C++ for Arduino, it is good practice to split your code into modular libraries. Stack H library file includes the class declaration listing public methods like push, pop, peek, and checks like is empty and is full. The logic for these functions are actually written in stack.cpp. This separation makes the code cleaner, more readable, and easier to debug or reuse if you need in other projects. Stacks operate using the last in, first out principle, just like a stack of plates. You add data to the top, and then you remove from the top. In the calculator, when you have a number and you press enter, it is pushed onto the top of the stack. When you press an operator, for example, plus, the top two numbers, B and A, are popped out, and then the operation is performed, so A plus B. And then the result of that operation is pushed back on top. This is where reverse Polish notation, or postfix notation, comes into play. This is where reverse Polish notation, or postfix notation, comes into play. Unlike traditional infix math, where 2 plus 3, RPN writes the expression in the orders that the operations are performed, so 2, 3 plus. This eliminates the need for parentheses or operator precedence. For instance, an expression like 5 plus in a bracket 1 plus 2 close bracket times 4 close bracket minus 3 is now 512 plus 4 times plus 3 minus. What this looks like when you're looking at it on the calculator, you'll have these three values stacked on top of each other, 2, 1, and 5. Now we have our operator here, so we pop the first two off, so 1 plus 2, push that back on, and I got 3 and 5 in the stack. Then we add 4 on top, 4 and 3 popped off, so now 3 times 4. That's pushed back on. Now we have 12 and 5. These are both popped off because of the plus, so now we add them together. 5 plus 12, we get 17. Now the 3 is pushed on, and we have a minus, so 17 minus 3, and that's 14. So that's the final answer. The evaluate function supports all basic arithmetic. addition, subtraction, multiplication, and division. It checks for divide by zero errors and only performs operation if the stack has enough values. The LCD shows two things: the current number being entered and the top of the stack after an evaluation. The result is formatted to 4 decimal places, providing clean and accurate feedback after each operation. The loop function constantly checks for a key input. If a number is pressed, it's added to a buffer string. If E or enter is pressed, the buffer is converted to a float and pushed onto the stack. If an operator is pressed, the calculator pops the last two number, performs the calculation, and pushes the result back. When powered on, the calculator greets the user with a splash screen before getting straight to work. The whole system is compact, reliable, and educational. Thank you for watching.